My dear students of Standard 10, good morning everyone. Welcome back to the chemistry class. Dear students, we are talking about Chatellier's principle. Already we learned about Chatellier's principle and we have completed the effect of temperature on equilibrium state of a reversible reaction. Chatellier's principle, that is, at the equilibrium of reversible reaction, if any of the factors, temperature, pressure and concentration of reactant is changed, the equilibrium position will shift in such a way that the effect of factor is neutralized. And already we learned that Chatellier's principle is applicable only for reversible reaction and when the reaction goes to equilibrium. We have completed the effect of temperature on Chatellier's principle, and the effect of temperature depends on the type of reaction, that is exothermic and endothermic reaction. For exothermic reaction, with increase of temperature, backward reaction rate increases, and with decrease of temperature, forward reaction rate is increased. And for endothermic reaction, with increase of temperature, forward reaction rate is increased, and with decrease of temperature, backward reaction rate is increased. Up to this, we had completed in our previous class. Today, we will discuss about the effect of pressure on equilibrium state of a reversible reaction. Effect of pressure change on equilibrium. We learned that effect of temperature, it depends on the type of reaction, exothermic or endothermic type. Effect of pressure is also not applicable for all reactions. Effect of pressure is applied for the reactions where all the reactants and products are in gaseous form. And there is another condition, that is the mole number of reactant and product will be different. If these two conditions are fulfilled by a reaction, then the pressure has effect on equilibrium of this reaction. Look, there are some reactions. Look, this is a reaction where sulfur dioxide and oxygen produce sulfur trioxide. Another reaction, production of ammonia by the reaction of nitrogen and hydrogen. This is also a reaction where nitric oxide is produced by the reaction of nitrogen and oxygen. Here, phosphorus pentachloride is decomposed to produce phosphorus trichloride and chlorine. And this reaction where calcium carbonate is decomposed to produce calcium oxide and carbon dioxide gas. Now look, there are 5 reactions, but all these reactions have no effect of pressure on equilibrium. First reaction, look, where all the reactants are in gaseous state and also product is in gaseous state. So the first condition is fulfilled here. And look, how many moles of reactants here? There are 2 mole sulfur dioxide and 1 mole oxygen. And in product side, there are 2 mole sulfur trioxide. That means there are total 3 mole reactants and there are 2 mole products. So the mole numbers are different. So this reaction has the effect of pressure on its equilibrium. Now look, this reaction here also, nitrogen, hydrogen and ammonia all are in gaseous condition. And there are total 4 moles reactant and 2 moles product. So here also pressure has effect on its equilibrium. Now look, this reaction. Here all these are in gaseous condition. Nitrogen, oxygen and nitric oxide. All are in gaseous condition. But there are 1 and 1. There are total 2 moles reactants and 2 moles product. So here the mole number of reactant and product, this is same. So here there is no effect of pressure on the equilibrium state of this reaction. That means here when the reaction goes into equilibrium, then if we change the pressure, it will not fall any effect on its equilibrium state. Now, next reaction, here also phosphorus pentachloride, phosphorus trichloride and chlorine all are gaseous condition, all are gas. And here there is 1 mole reactant and there are total 2 moles product. So, here also pressure has effect on the equilibrium of this reaction. And look, there are calcium carbonate, it is in solid condition, and calcium oxide, it is also solid. So here this reactant, it is solid and one of the product is solid. Only one product, carbon dioxide, this is gas. So here all the reactants and products are not gas. So this reaction has no effect of pressure on its equilibrium. Now, effect of pressure change on equilibrium. At first, we will discuss the effect of pressure change for more mole number in reactant side. Look this reaction. Here in the reactant side, there are total 4 moles reactant and there are 2 moles product in the product side. So the mole number of reactant is more than product here. Now for this reaction, the forward reaction, you know that when ammonia is produced from nitrogen and hydrogen, then this reaction is forward reaction, and when ammonia is decomposed to produce nitrogen and hydrogen, this is the backward reaction of this reversible reaction. Now, in this reaction, if pressure is increased, look, here the mole number of reactant is more. Where the mole number is more, there the pressure is also more. So, in the reactant side, there is more pressure than product. So, in this condition, if pressure is increased in this reaction, then what will happen? The reaction will go to forward because more product is produced from the reactant. Forward reaction rate is increased because in the product side the mole number is less than reactant, so here pressure is also less. So this forward reaction minimize the increased pressure of the reaction. So when the mole number of reactant is more than product, then with increased pressure, the forward reaction rate is increased. So more ammonia is produced by the reaction of nitrogen and hydrogen. The mole number of product is less. So this forward reaction minimize the increased pressure and equilibrium will shift into right side. Okay, now if pressure is decreased for this reaction where the mole number of reactant side is more, then what will happen? If pressure is decreased, then the reaction will go to backward. That means more reactants are produced. Here the mole number is more, so the decreased pressure will be increased by occurring the backward reaction by producing the more reactants. So here look, with decrease of pressure, backward reaction is occurred. Some ammonia is decomposed to produce nitrogen and hydrogen. The mole number of reactant is more. This backward reaction increases the decreased pressure and equilibrium will shift into left side. Now another example where the mole number of reactant is more. For more mole number in reactant side, already we learned that for more mole number in reactant side, if pressure is increased, then forward reaction rate will be increased. That means equilibrium will shift into right side. And if pressure is decreased, then backward reaction rate is increased. And we know backward reaction rate, if it is increased, then equilibrium will shift into left side. Now look this reaction here also. The mole number of reactant side is more than the product. So for this reaction, if pressure is increased, then forward reaction rate will be increased. More sulfur trioxide is produced and equilibrium will shift into right side. And if pressure is decreased for the reaction, then equilibrium will shift into left side. That means backward reaction rate will be increased and some sulfur trioxide is decomposed to produce sulfur dioxide and oxygen. Now we will see if the mole number of product side is more, then what will happen if pressure is increased or decreased. For more mole number in product side, look an example here. This is the reaction where the mole number of product is more than the reactant. Here in this reaction there are two reactions, one is forward and one is backward. Forward reaction is this part, that means when PCl5 is decomposed to produce phosphorus trichloride and chlorine, this is the forward reaction of this reversible reaction, and in backward reaction phosphorus trichloride and chlorine make phosphorus pentachloride. This is the backward reaction of this reversible reaction. Now in this reaction, look, if pressure is increased, what will happen? When pressure is increased, then the increased pressure should be minimized. How? Here in the reactant side, there are less mole number. That means there is less pressure. So, reactant will be produced. Then the increased pressure will be minimized. So, in this reaction, if pressure is increased, then backward reaction is occurred. The rate of backward reaction is increased. That means more phosphorus pentachloride is produced from phosphorus trichloride and chlorine. The mole number of reactant is less. This backward reaction minimizes the increased pressure and equilibrium will shift into left side. And opposite phenomenon will occur if pressure is decreased. If pressure is decreased, then forward reaction rate will increase because here in the product side there are more mole. So the decreased pressure will be increased by producing more product. So equilibrium will shift into right side. If pressure is decreased, then forward reaction is occurred. More phosphorus pentachloride is decomposed to produce phosphorus trichloride and chlorine. The mole number of product is more, so this forward reaction increases the decreased pressure and equilibrium will shift into right side. This is the effect of pressure on equilibrium state of a reversible reaction where the mole number of product is more than reactant. Now we will discuss about the effect of concentration on equilibrium. This is very easy. Effect of concentration: if you increase the concentration of reactant, then the forward reaction rate will be increased. That means more product will be produced from reactant to minimize the change of concentration. And if you increase the concentration of product, then more reactant will be produced. That means backward reaction rate will be increased so that the change of concentration will be minimized, can be minimized. With increase of concentration of reactant, equilibrium will go to right side. That means forward reaction rate is increased. And with increase of concentration of product, equilibrium will go to left side. That means backward reaction rate is increased. Now, some industrial production where La Chatelier's principle is applied for getting more product. You have to remember one thing, that in industry the reactions are occurred for getting the product, more product. There are some important reactions where one is synthesis of ammonia. Ammonia is an important ingredient in fertilizer industry. In fertilizer industry, at first ammonia is produced from the reaction of nitrogen and hydrogen by this reaction, and already we know this production of ammonia, this reaction is a reversible reaction, and always the factory wants that more products will be produced. By which way more products can be produced? By occurring forward reaction. Backward reaction is a loss project. So the Chatellier's principle will be applied in a way so that the forward reaction rate can be increased. More product can be produced by the reaction. Another important reaction is oxidation of sulfur dioxide to sulfur trioxide. You know, sulfuric acid is an important compound in different industry like pharmaceutical industry, fertilizer industry. In different industry, sulfuric acid is very important. Sulfuric acid is produced from sulfur trioxide. So to produce sulfuric acid, at first sulfur trioxide should be produced, and sulfur trioxide is produced by the oxidation of sulfur dioxide by this reaction. And this reaction is also a reversible reaction. So Chatellier's principle is applied for getting more yield from these reactions. Now we will read how we will get more product from these reactions by applying Chatellier's principle. At first, synthesis of ammonia. Already we know that this is an exothermic reaction, and we know for exothermic reaction, if temperature is increased, then the forward reaction rate is increased. But this is a loss project. We should increase the backward reaction rate, so temperature should be decreased here. Again, we know that at low temperature the rate of reaction is very slow. So to minimize all these problems, to solve all these problems, the optimum temperature is maintained here 450 to 500 degrees Celsius. Look here. We know it is an exothermic reaction. According to the Chatellier's principle, for exothermic reaction with increase of temperature, backward reaction rate is increased. So at low temperature, forward reaction rate will be more and more product should be produced. But at low temperature, the rate of reaction becomes very slow. So to minimize the problems, 450 to 500 degrees Celsius temperature is taken as a standard temperature. Here the temperature problem can be solved. Now pressure. We know here the mole number of reactant is more and mole number of product is less. So by increasing pressure, more product can be produced from there. But there is a problem. When pressure is taken as more, then costly equipments are needed for carrying out the reaction. So here catalyst can be used, and by using catalyst at low temperature or at low pressure or at medium pressure like 200 atmospheric pressure, maximum yield can be produced. Here iron powder is used as catalyst. Again, the mole number of reactant is more than the product of the above reaction. So by increasing pressure, maximum yield can be obtained. But at high pressure, costly equipment are needed to maintain the reaction. If iron powder is used as catalyst, then the problems can be solved. So ammonia is produced from nitrogen and hydrogen by applying 200 atmospheric pressure in presence of iron catalyst. So the maximum yield of ammonia can be obtained at 450 to 500 degrees Celsius temperature and 200 atmospheric pressure in presence of iron powder mixed with magnesium oxide, aluminium oxide and silicon dioxide catalyst. These are the catalysts that increases the rate of reaction. So this is the condition. By following this condition, we can get maximum product ammonia from the reaction of nitrogen and hydrogen. The conditions are: the temperature remains 450 to 500 degrees Celsius, pressure is 200 atmospheric pressure, and catalyst iron powder mixed with magnesium oxide, aluminium oxide, and silicon dioxide. By applying all these conditions, better yield can be produced in industry by the reaction of nitrogen and hydrogen. Now another production, that is oxidation of sulfur dioxide to sulfur trioxide. Look, this is also reversible reaction and also exothermic reaction. Here also the optimum temperature remains as 400 to 500 degrees Celsius. And here, by applying only 1 atmospheric pressure in presence of catalyst platinum or vanadium pentoxide, maximum yield, that means 98 to 99% sulfur dioxide is oxidized to produce sulfur trioxide. Here I am not explaining in detail because the explanation is same as before. Just here I am writing the condition here. Here the temperature is 450 to 500 degrees Celsius, pressure 1 atmosphere pressure, 450 or 400, anyone can be granted, and catalyst are platinum or vanadium pentoxide. By applying this condition, we can get maximum yield, or we can get 99% yield from the oxidation of sulfur dioxide. So dear student, this is for today. We have completed the chapter here. You will solve the exercise. I will come with some new topic in our next class. Thank you everyone. Goodbye to all.